This is Dr. Mohalakshmi, Professor and Head Department of ECE from Rohini College of Engineering and Technology, Kanyakumari District. So in this lecture we will be seeing about the power amplifier and how it is classified. So power amplifier, you can see the block diagram over here. So where you have a DC power supply and that is a small signal amplifier, which in turn it is given to the power amplifier. So you have an output power. The example here it is given with the speaker, that is audio power amplifier. So here eta will give you the efficiency of the amplifier, and P out is the amplifier output power which is delivered to the load, and PDC is the DC power taken from the supply. So the ratio of these two will give you the efficiency of the amplifier in percentage. So factors of consideration. In small signal amplifier, the main factors are amplification, linearity and gain. Since large signal or power amplifiers handle relatively large voltage signals and current levels, the main factors to be considered are efficiency, maximum power capability, impedance matching to the output device. So how it is classified? So it is classified according to the output signal waveform, which varies over one cycle of operation for a full cycle of input signal. So it can be classified as class A, class B, class AB, class C and class D. So here this is the general graph given for the various amplifier types. And coming to the amplifier types, we will shortly see or a very brief discussion about the amplifiers. So in the class A, it will conduct through the full 360 degree of the input. So the output signal will vary over one cycle of operation for one complete cycle of input signal. The Q point is set or biased near the middle of the load line so that at least half output signal may vary up and down without going to saturation or cutoff level. So the power efficiency is about 20 to 50%. So class B, the power efficiency is good compared to A, which is 78.5, and the Q point is set near the cutoff point, or that is at the cutoff point. So this will be conducting for 180 degree of the input, which means that only half of the input signal. Coming to class AB, this is comprises both A and B, and it will be the swing occurs between 180 and 360 degree. So this Q point will be located at the DC level above the zero base current of class B and above one half of the VCC level of class A, that is in between the midpoint and the cutoff. So the power efficiency is around 50 to 78.5%. Coming to the class C amplifier, it conducts less than 180 degree of the input. So it is biased below 1 IB, 0 IB, that is located below the level. Power efficiency is high, about 90%. And lastly, the class D, this is biased especially for digital signal. So its output is like a pulse signal, which is that is on for short interval and off for a larger interval, which you can see from your waveform, which is at the down using digital techniques. So these are the very brief introduction about the power amplifier types. So what are the performance quantities of power amplifier? So this could be like collector efficiency, power dissipation capability and the distortion. So what is collector efficiency? So this is not the power gain but the maximum AC power output. So an amplifier, obviously we know that it will convert a DC power from supply into an AC output. Hence the effectiveness of a power amplifier is measured in terms of its ability, which could convert DC power from supply to AC output power. This is called collector efficiency, and it is normally defined as the ratio of output power to the zero signal power or DC power supplied by the battery. And this is actually the efficiency expression where it is given for the AC power output to the DC power input. So DC power is given by VCC into IC, whereas P0, that is output power, is given by VCC into IE. Coming to the second factor, which is distortion. So any change of the output shape from the input wave shape of an amplifier is known as distortion. So the transistor is a non-linear device, so the output is not exactly like the input signal applied to it, which means a distortion occurs. And the next one is power dissipation capability. So any power transistor, it should dissipate heat, which is known as power dissipation capability. So this could handle large currents and hence it could heat up during operation. Since any temperature change influences the operation of a transistor, therefore the transistor must dissipate this heat to its surroundings. To achieve this, normally a heat sink is attached to a power transistor case. So the increased surface area allows heat to escape easily and keeps the case temperature of the transistor within permissible limit. Thank you.